We are from Group T, Course Analysis of Mechanics and Machine, under the Mechanical Department in Faculty of Engineering, UNIMAS. This video is to explain how we tackle a problem faced by physically unable people in cases of an emergency. In this modern era, the wheelchair plays a very important role in aiding physically limited people. The wheelchair improves the quality of the life that are in need. Mobility is an essential factor in our daily life. The wheelchair is usually found in health facility or elderly home to aid the patients. Nurses in duty are responsible in assisting the patient. Therefore, we opt to design an electric and automated wheelchair that can get to the nurse in an emergency. We want the wheelchair to be able to arrive at the nurse within 1 minute of a 30-meter diameter area.
Now, how do we start with this project? Well, we had a group meeting to decide how to run this project smoothly. We have then come out with this flowchart to help us proceed throughout this task. We started with identifying and analyzing the problem and the required factors of the problem. We magnified the scope to better understand how to tackle the problem. After our finding, we discussed and chose the best design together. We prioritize functionality and safety for our wheelchair, and we ensure that comfort is also important in our design. We would then distribute the task among the group members. After the distribution, the design started in AutoCAD. We use functions such as line tools to construct our wheelchair. After finishing the wheelchair in AutoCAD, we import the design into Working Model 2D to simulate the wheelchair. Pins and motor are then attached to the rear wheel.
Now, the design of the wheelchair is, as we said, prioritizes safety, functionality, and comfort. Therefore, we opted to use aluminium as our material for the frame. The reason behind this is because aluminium has a high tensile and compressive yield strength. Also, aluminium has the benefit of being resistant to corrosion. Aluminium is significantly cheaper than other materials such as titanium. Also, aluminium has a low density which makes it lightweight and portable. The processing unit and batteries are connected at the bottom of the handle to ensure that it is accessible. Moving on to the wheels, the rear one has a 60 cm diameter and the front wheels is 14 cm in diameter. The tires are comprised of solid rubber. This is due to its reliability and also the minimum amount of maintenance required for the tires in compared to other methods. Even though solid rubber tires make a more bumpy ride, the efficiency and safety of these tires pay off for the bumpy ride. The cost of manufacturing solid rubber tires are much more cheaper than other materials. Therefore, this way of implementing the tire is the most efficient. There will be two types of motors installed in our wheelchair: a 24-volt brushless DC motor to rotate the rear wheels and a 12-volt brushless DC motor to navigate the wheelchair's direction. Two 12-volt batteries will be installed at the processing unit to provide electrical energy to the DC motors installed. There will be 3 sensors installed in the processing unit and wheelchair: a GPS, an infrared sensor, and a speed sensor. The GPS is required to calculate the vicinity area on the XY plane. In the 30-meter diameter area, the GPS is required so the wheelchair knows where it is in the area. Speed sensors are installed to know how fast the wheelchair is moving. The speed sensor also acts as a speed limiter so the wheelchair does not exceed dangerous speeds. The infrared sensors are installed to emit and receive infrared radiation to detect objects around the wheelchair. This is to avoid and react to objects around the wheelchair while the chair is navigating to the nurse. These 3 sensors are used together to guarantee that the wheelchair can navigate to the nurse safely and quickly. Here shows how the input from the sensors can output signals to the processing unit to calculate how much power the wheels need and where to go. The block diagram is here to help ease us understand how the wheelchair functions. An infrared receiver and emitter is also required for the nurse. Also, the patient will also have an infrared emitter and receiver to call the wheelchair to the nurse.
So, after our research and discussions, we can refer to John Canuck in 2017 on the types of DC motor used. Now, we found out that the DC motor that he used has a nominal torque of 34 Newton meters. After that, we applied the 34 Newton meters into our simulation and run the simulation. We also had a 30-meter plane in the simulation to simulate that there is a 30-meter diameter area that the wheelchair will run through. Now, after observing the simulation, the wheelchair is able to run through that 30-meter diameter or length in under 1 minute. Therefore, we can conclude that the wheelchair is functional in the real world and can be applied in the real world. The patient can call the wheelchair to the nurse in a case of emergency, and we can ensure that the wheelchair is safe, comforting, and also functional. That is all for our video. Thank you very much.